everything was going to be fine. Everything's not fine. Welcome back, airheads, to the Gentleman Z06 build part 2. Let me show you what we're working on here for this weekend. So I think what I'm going to dive into for this weekend, depending on how much time we get out here, is the cylinder heads. So the cylinder heads have been fixed or reworked, as the LS7 community likes to call them. They were done by Texas B back in 2018. I think they have, I don't know, somewhere between maybe 10 to 12,000 miles on them, with a pretty aggressive cam, close to 660 lift, pretty aggressive lobes. So they should be, theoretically pretty beat up in that sense, but I'm hoping that there's not going to be any issues with them, that this LS7 valve guide valve failure issue is a permanent fix. So I'm curious to dive into these this weekend and kind of learn a little bit more about this fix, and if it's permanent or not, or if we're back to square one, as we found this car originally with about 20,000 miles on, and the valves were completely, or the valve guides were completely wore out, where they had a ton of play, a ton of wiggle in them, as we like to call it. So here's what we got going on here. We'll first start with the pressure test on the heads. Since they're already assembled, this is an easy time to do it now. So kind of my concept or idea here is I'm going to take a piece of plate steel. I'm going to cut it out kind of in shape of the port. So I'm kind of going to try and make this as universal as I can. So the exhaust port and the intake port I could cover with this. And then there's going to be a little hole here. And on the back side of the plate is going to be rubber gasket material, so it actually can seal up against the port here. And then what I'm going to do over here is build up a little vacuum pressure test rig. So I have here basically an air ejector that'll be driven off my air compressor. I've got a vacuum gauge here. I got some ball valves, and then I got a couple miscellaneous fittings, some T's, so I can make up this little jig. So by you driving pressurized air or fluid, either an adductor or an ejector, and pushing it through this nozzle, it creates a low pressure here, so there'd be suction, and then both the air or whatever fluid you're sucking out here and mixed in with this air fluid here is all going to be basically pushed out this way. So it's an easy way to create a low pressure point or vacuum by using a driving force like a compressed air, compressed fluid, or water or something. So that's what this little guy here does. I picked this up off Amazon, I think, for like 10 or 12 bucks. So you'll see here you have a pressure port, and then here you have a vacuum port. So compressed air hooked up. This will be the suction port on the cylinder head over the intake or exhaust port, and then this will essentially be like the exhaust. Here's our final product, made in our very high-tech fancy machine shop we have here. So just a piece of rubber gasket glued to the back of this plate. We got a vacuum gauge on one side and the little ejector thing, and that's our compressed air hookup. So I don't know how well this is going to work, because essentially this has to seal against the port, pull vacuum on the port, and then test how well the valve is sealing. So I don't think this thing is going to be able to, like, where you pull vacuum on it, shut the valve off and then have it hold, because I don't think the gasket's going to seal well enough. But if it does pull vacuum, that should mean that the valve is sealing pretty well. Like if I didn't pull any vacuum, or maybe 5 inches, then it wouldn't be very good. But if it pulls like, I don't know, 10, 15, I would imagine that's like a pretty good seal on the valve. Maybe an engine builder or somebody that does this professionally could chime in, or machined cylinder heads, because I don't know how accurate this is going to be. I just figured it'd be like a good kind of rudimentary basic test to just see if the valves would be sealing without taking anything apart yet. So we'll see what we get. Let's test this out. All right, so it kind of did what I expected in a way. So if you see the scale on the gauge, basically 0 to 30 inches. The exhaust ports, they all pretty much pulled, I guess like 22, 23. And then all the intake ports pulled around 15. I think it was between like 10 and 15. And as I was doing it, I was kind of like pushing in and then wiggling a little bit, and you could see the change in vacuum, like, so it was better sealing against the port. So I think likely this thing isn't probably perfectly flat and perfectly sealing against the port, but it is able to pull a pretty deep vacuum when you hold it up against the port. So that to me would mean that the valves are sealing pretty well. I don't know if we have 100% conclusive results doing this method, but I think it was just kind of a cool little experiment to try out. I think if the valve was really bad though and wasn't sealing at all, there's no way to be able to pull that deep of a vacuum. Like the leak would be worse than the amount of vacuum, so therefore the pressure wouldn't come up, like maybe be only pulling 5 inches or something, but certainly get into 15, 20, even past 20 inches of vacuum. I think it's pretty well sealed. So I'm going to wrap up this part for tonight and then come back out in the garage tomorrow early Saturday morning and break these heads down. All right, now moving on to the fun stuff. We got the tool load out here we're going to need for doing the valve stem to guide inspection. You'll see here we have this fancy and expensive LS7 valve spring tool. You don't necessarily need this. The benefit of using this tool and spending the money is that basically it pushes the valves straight down instead of the other tools that kind of like mount in the rocker and they use kind of like a pivot and push down the valve. Those can actually side load the stem and cause damage to the stem or the guide itself. So this is why, you know, you'd spend, I don't know, this thing was probably 150, 200 bucks to get this specific tool over using the cheaper like comp cams ones that are maybe $30, $40. So anyway, you can go either way with it, but this is just what I had from the last time I did this on the car. So the other key component to this test is having this test indicator. So it's a fancy little kind of dial indicator, but it's actually called the test indicator. It measures very small increments of movement basically, and it allows you to position this in the way to get to the base of the valve stem, right where it comes through the guide and the cylinder head. Because you'll notice from a side profile, you know, this aluminum comes up. So if we took our regular dial indicator and put it up here and then rocked the valve stem back and forth, that's not going to get you an accurate measurement because you're basically adding that additional length of the stem, and you'll notice my index finger, when I rock it, moves a lot further than my thumb. So that's why you want to measure at the base to get the most accurate measurement of that valve rock, the wiggle test, or valve stem to guide clearance. This is something else I forgot to mention about the dial indicator versus the test indicator. In order to accurately measure something with the dial indicator, you basically need to be perpendicular to your workpiece. You can't really be at any type of acute or obtuse angle. So that's something that's a benefit with the test indicator. Is a test indicator can accurately measure these deflections or whatever you're trying to measure run out in something at very acute angles. So that's what makes this tool a little more versatile versus a dial indicator. So just something else to keep in mind if you see somebody taking measurements with a dial indicator at like an angle or something like this, that's not accurate. I just got the first one apart, springs, keepers, seals, and I just have the valves. Essentially they're sitting on the workbench top. So this one's the intake. You can see there's no play here. I can't even rock the valve at all. And then this one's the exhaust. This one, we have a little bit of play in it. So there's definitely some wear here in the last 10,000 miles in the exhaust valve. And these were replaced, so these are stainless steel valves. These are the original intake valves that were just polished. So these are a new valve, and basically the CHE bronze guides. So let's get the test indicator set up, and we'll get an actual measurement on this and then compare it to what our spec is in the book. All right, so here's our first measurement. We're basically getting 4 thousandths. So each line or tick on the dial faces half a thou. So we got 1, 2, 3, 4. All right, here's the setup and the measurement on the next cylinder. So we got 3 thousandths on this one. So pretty close to the other one. And let me just show you the setup there again. So see where it's sitting at the top of the guide. Basically, I'm just coming behind it. I have it zeroed out. Lift the valve up a little bit so it's off the, it's not on the bottom and it's not on the seat. So it's like right in the middle. And just give it a little rock back and forth. You can see that tiny little bit of movement. That's the 3 thousandths right there. So here's our final measurements. Again, listed down, driver's side, passenger side. So our highest one was cylinder 6 exhaust 065. The rest of them are pretty much between 2 and 3,000, so we had a couple 4s there. Intakes are all 0. So here's the factory service manual. Gives you all the mechanical specifications. So you see here 7 liter, that's what we're working on. And you go down here to the valve stem to guide clearance, and you have production and then in service. So service would be probably what we're looking at, since this is a service inspection and these are not new, it's used. So 0037, so a little over 3.5 sevenths. Intake and exhaust are basically the same. So the intake were all good. The exhaust were actually out of spec on quite a few of them. So any of them that are over 0037 are technically out of spec. So our 1 exhaust, our 7 exhaust, and our 6 exhaust are all out of spec. And just to show you guys the condition of the valve seats and then the contact area on the disc. So you can see that nice clean contact area. So that means this valve is probably more than likely sealing really well. There's a little bit of carbon buildup on the backside of the valve, but that's to be expected. And then same thing on the exhaust valve. The exhaust valve has a little bit of deposits on the face there, but nothing too bad. I don't think anything that you took a little lapping compound and clean those up, they'd be totally fine. And just to flip these around so you can see that nice ring, clean ring there, that's the seat area. Looks super good, so I don't think we had any issues with valve sealing. So that's just another kind of inspection point. You want to make sure obviously your valves are sealing good. But if we got to do guides, then I would imagine they got to put the new guides in, they got to ream them, and then they likely got to recut the seats so everything is essentially concentric around the guide. So I'll have to talk to a local machine shop, figure out what our next steps are here. But I think this is going to wrap this part of the video up because we're kind of at a stopping point right now. So I decided to do one more test just to kind of test the accuracy of the wiggle test we're doing with the test indicator tool. So what I decided to do was break out a little snap gauge or telescoping bore gauge. So if you guys haven't seen one of those before, it's basically just comes in a set and they can do various sizes. You essentially collapse it. All right, now we've gone hands-free so I can show you. You basically collapse it, you'd then put it in the bore, you'd snap it, let it telescope out till it's hitting each side of the bore, and then you'd lock it down here and then you slide it out of the bore, and then you could take an outside mic and then you can measure pretty accurately the dimension. So we just have an extremely small one. This, for instance, does, I think, 8 mil to 13 mil or 5/16 to a ½ inch. So this guy's pretty small, but he actually fits inside the bore of the guide, and then we can basically pop it out, lock it, slide it out of the bore, and then we take our measurements. So I'll give you guys a quick demo on doing this. So I got it collapsed right now and locked. I'm going to put it in this number 7 exhaust. Basically, I'm going to loosen that up, allow it to snap out. I'm going to do the top of the guide here on this one. Lock it in, and then pull it out of the guide. So now we have our locked in measurement here. Then we're going to go over to our outside mic. And we're going to put our snap gauge in. And we're basically going to snug this up just until we feel it touch, and we could still kind of rock it. So right there, it's about where I feel it make contact. Okay, so you can see on the scale here, we have 0.316, and we're just past that 6. So then we go over to the vernier scale. So we got 316 and then 1. So where that's lining up right there. Then we take our stem diameter, which I mic'd these out. They're both the same. So we have our measurement of 3161 minus 0.3135 for the stem. And then we get our clearance of 0.0026. As you see, the exhaust here, upper 0.0026. So that's how we came up with all these measurements here. So what I did was I took measurements for each cylinder, exhaust, and intake, and I did them at the upper, the middle, and the lower point of the guide, just to see if there's any difference between the length of the guide and then taking it upper, middle, and lower. So these are all the numbers. Basically, things did come down a little bit from the wiggle test we did with the test indicator. So you can see here from our old, or not old, but from the other measurement method we did, we basically had cylinders 7 exhaust, 6 exhaust, and 1 exhaust were out. So then if we flip to here, our 1 exhaust was just within, so 3.7 is the limit. But you'll notice here the lower and the middle part of the guide had almost no wear, so just the upper part of the guide. And then you come down here, we had a little bit more wear on the lower part of the guide here than the upper, but we're within spec technically, it's 3.7. And over here, this was the only one that was out, which was 6 exhaust. So we had 4.5 lower, 4.5 middle, and 5.5 upper. I had to remeasure that one, didn't come out right the first time. So this is the only one that was technically out of spec using this method. All right, guys, well, this is a bit of a bummer. I didn't think this inspection would yield the results it did. Kind of assumed we were going to tear everything down. Everything was going to be fine. Everything's not fine. And then we were going to reassemble it all, maybe a little skim cut to boost the compression up, clean everything up, and they go back on the car. But now it looks like we're going to be reworking the heads again. So I'm going to have to dive into this, do some more research, see if there's anything that's been developed since 2018. I mean, this was 7-8 years ago since we did the build, so maybe guys have learned some more things over the last 7 years. I don't know if we're looking at roller rockers, if we're looking at different valve guide material. I don't know what guys are doing now, so I don't think the bronze guides are the fix with the stainless steel valves. Maybe something with the rockers is still kind of side loading the tip as that aggressive rocker ratio you have. If that rocker is pivoting down and it's kind of pushing not centric on the stem, and then that causes the stem to kind of deflect ever so slightly, and you're doing this over and over and over again, especially with having a higher lift cam, that's going to cause the rockers to flex down even more and then maybe push on the stems worse than they would if this was a factory cam. So I don't know, I've got some mixed feelings right now going on, but we still got to charge forward with this project. We got to get this car fixed, get it back together, get it out on the track. So we're not going to let it slow us down, not going to let it stop us. We're going to hopefully find a permanent solution this go around. But, you know, that's just kind of how some of this stuff goes. It's lessons and learning and adapting, modifying, and then finding maybe the permanent solution. So I'm going to cut this part of the build series off here and join us back for part 3 of the Gentleman Z06 build, and we'll see what we find out when we talk to our local machine shop here and see what they recommend.